CQ Sat, Mike 0 Yankee Kilo Sierra, Italy Oscar 93 Charlie Uniform listening. Mike 0 Yankee Kilo Sierra, Italy Oscar 93 Charlie United.
Mike 0 Yankee Kilo Sierra, Fox 1, Fox Papa Lima.
Fox 1 Foxtrot Lima, thanks very much. You 5x9, Italy Oscar 93 Charlie Uniform, good evening.
Okay, my call sign is Fox 1, Fox Papa Lima, F1 FPL, you are 59, Juliet, November 09, Lima, Echo,
Fox 1 Fox Delta Lima, thank you very much for the nice report. Catch you again on another path. 73. Sorry about that. Fox Papa Lima, got it that time. Fox Papa Lima, thank you. Bye bye, thank you. So yeah guys, I'm just messing around, and sometimes it's quite tricky. That was a satellite SO50 which has just come over. I've been making quite a lot of videos on these satellites lately, and I decided to do it for some of you guys that are thinking about getting into the satellites. So today, this particular video is a little bit different. That was just a quick demonstration of me working an FM satellite using my amateur radio ground station. So I'm going to tell you a little bit about some of the basics and some of the things you might want to consider if you're thinking about trying it out as a newbie, someone who's going to get into it. So welcome, and sit back, and this is a bit of a presentation, if you like, on how to work the satellites. So I'm going to talk over this, and we'll start off with this slide here. So it's all about getting you interested and telling you one or two little useful tips which might set you up and help you on your way. Before I start, I just want to say I'm no expert in this. There's people with a lot more experience and bigger stations than what I operate, but I've had about 20 years worth of experience, and I've really enjoyed it, and I'm still learning. It's a fantastic part of the hobby, and sometimes you'll be surprised just how well you can do with the easiest and simplest setups. So this is a basic look at some of the antennas where I commenced my satellite career, if you like. Starting off with the homemade broomstick Yagi. That was just a simple 145 element antenna, which I knocked up with some flat sheet and a broomstick, and I used to receive I think it was VO52, good old SSB satellite, and a lot of the weather satellites on 137 megahertz on FM, the NOAA sats. So that's how I started off. I ended up tilting that to a 30-degree angle, and that was a pretty optimum kind of setting for that antenna. When you move to the next antenna, the yellow center boom, that's actually an old garden shovel plastic boom, and I've used some welding wire, and that's what you call an IOIo antenna. Very popular when I first started getting into satellites, and it was a Spanish station. I think it's Echo Alpha 4 Charlie Yankee Queen. We'll find out on the next slide, but basically I got the idea off that particular person, got the design, and made that one quite simple. So it's two loops. You've got a 145 megahertz loop and a 435 megahertz loop at the front, and both have got what they call reflectors at the back. Hence, if you turn it to its side, it's IOIo, and that's a really good VHF UHF starting point when you've got a couple of handhelds, two feed lines, two radios, one for transmitting, one for receiving, and you can wave that around all day long with it being a plastic garden, we'll say tool boom handle. To the right of that, that's what I'm currently using. So a lot more sophisticated, controlled by a computer with a rotator which can elevate and turn and basically follow the satellites, the space station. But as you can see, you can do all that in the bottom picture. You've got the tripod mounted arrow antenna, which is two bands, 145 and 435. Pick them up for reasonable cost. They're quite pricey, but you can make your own. Any 2 meter 77th beam will work, and you can use a simple camera tripod if you wish, or hold it by hand. Some people like to use duplexers and use one radio. I prefer to use two, an uplink and a downlink, and that way you can hear yourself when you're making it into the satellite or the space station. To the left is a picture of the IOIo, and to the right is my current station. which comprises of an FT847, G5500 azimuth elevation control unit, and above that is the COM232B, which is a simple interface connected with a cable to the PC, and it's just a serial USB cable with the latest chipset, and that is then controlled by the software to the right, which is SAT-PC32, which controls frequency correction and also antenna position. So a couple of terms on the first page. AOS, people get confused with that one. It just simply stands for acquisition of signal, or satellite, or ISS, whichever you're listening to. So when the signal starts to come in at that time, and then you can see it rises above the horizon of the observer, and as that happens the signal obviously increases if your antenna can follow it. The TCA is with the time of the closest approach, and that also is when you've got the biggest change, what we call the Doppler shift. So it's come right down to the 0 center point, and you probably started off maybe 5 or 10 kilohertz up on the receive pass, and you'll go down a further 5 or 10 after the center point has been received. That's due to the Doppler shift. So you've got to change your frequency as the satellite or space station approaches and passes by. So it generally starts higher and you tune down. So that's the pictures of a couple of antennas for you to think about. The one on the left is the one I made. That's got a wooden boom, and I used some 12mm aluminium bar to make the two loops, which one is 145 megs, one is 435, and we call it the IOIo. In that particular case, I decided to try one horizontal and one vertical on the polarized pattern by mounting them differently. To the right, once again, it's the Arrow dual band satellite antenna with the two handhelds on the tripod. I've been recently making the videos demonstrating this particular piece of kit. I've had it for nearly 20 years, still going strong, a really good investment, and I've made hundreds, maybe thousands of contacts on it using 4 watts QRP. So two handhelds or one, well, that's entirely up to you. You can have use one and a duplexer, or you can have the comfort of hearing the signal coming back down as you're transmitting. And of course some radios are capable of doing that, and they are full duplex. The one on the bottom is a full duplex radio, but I still prefer the separate control of the uplink transmission, which is the one on the top in this case, and then I can change the channels or the frequency, if you wish to call it that, quite easily on the bottom receiving radio. So that's my preference. However, you can use a duplexer, which I'll talk about in a minute. So going back to the IOIo antenna, this is the one that I used for many years and I had lots of success with. I get a lot of inquiries and interest, and on one of my websites I've actually got a download page with details where you can just download this particular printout which I've created. It's all courtesy of Echo Alpha 4 Charlie Yankee Quebec, who originally put the dimensions on the internet, and I've been making them ever since. So this is my drawn up version of those dimensions, and again you can find it on my website. Just type in my call sign in Google, M0YKS, and you will find the ham radio website that I've got with a download page. I can put a link at the bottom of the video for you to follow. So that's the information telling you all about the dimensions of the IOIo dual band satellite antenna, which can be handheld or fixed. In my case I tried both, and the fixed one I decided to fix it at a 30-degree elevated angle, and it's still doing the job now. I think it's been up for 20 years. That's up at my holiday cabin. So 30-degree elevation angle of the antenna pointing upward gives you a very good kind of broad range of working satellites if you've not got elevation on your rotator. And if you've not got a rotator, just stick one of those at an angle of 30 degrees and see what you pick up in a certain direction. But obviously with a rotator they can be quite effective with a 30 degrees mounting angle, and that's all you really need to get going. I've still got mine at my holiday cabin, and it works fine. Obviously not as versatile as a full elevation rotator, but at a 30-degree angle fixed it works pretty well. So duplexers then. Personally I don't operate with a duplexer due to the fact that the satellite signals are so low and weak that any desensing of signals can cause you not to hear it. So I like to operate without the duplexers in all cases, and I would never recommend it personally. However, it's a popular choice for a lot of operators, and obviously it works. But it's usually where you transmit and you don't hear the signal as you're transmitting, so you don't really know whether you're hitting the bird, but a lot of people operate like this and they have lots of success. So there's lots of different types of duplexers. Some people might say, what is a duplexer? So it's just simply a method of fastening either one antenna, which is a dual band, a two-banded antenna, say for example 145 and 435 megahertz antenna, two sets of elements, into one feed point, into one coax, and then that can then be split off to two separate receiving radios, or two inputs on a radio which has two separate VHF, UHF receiving points. I generally don't use them, but they can work like that. Other methods, of course, can be the other way around, two separate antennas into one radio, separately connected with a duplexer. That's how it works on the Arrow. So you've got one connection to the VHF antenna elements and one connection to the UHF antenna elements, and then the final single connection going to the transceiver. So you can use them either way really, and they are very good. A lot of them come with filters which do help, but like I said, I prefer the direct feed method with two separate feed lines. I'm just giving you my personal preference and opinion, and the things I've found that work for me over the 20 years or so that I've been working satellites. So what you're looking now is a good online resource which I've been using through my phone when I'm out and about, and quite often on the PC. So this is a great method of finding out what active satellites, or should I say which birds are going to be in range and what path they're taking. Also, if you look to the right of the data in kind of reddy orange colour below the clock, you can see that you've got the frequency readout of the bird. So in this case we're looking at XW2A, and it's telling us that the uplink is 435.036.25 at the current moment, and it's receiving downlink or transmitting downlink to us is on 145.674.13, and that is on USB. The uplink's on lower sideband, so we've got an inverting linear transponder, that's what they call it, when you've got one mode going up, LSB for example, and one mode coming down, USB. A lot of these SSB birds do also operate CW, and they also have a beacon telling you, obviously you can hear the signal approaching. So on that particular software, which is just a simple website, the address is at the top of the page. It works on any kind of phone, any PC, it's just a web browser, and it's pretty good. Always up to date, and gives you the information such as the azimuth position and the elevation. And you can just simply click on any particular satellite, and you can focus on that particular one with the footprint highlighted. The footprint is generally anybody who is within that circle can make a contact if they have a reasonable antenna system. On the page you can also see you've got options to change it to SSB, SSB plus FM, weather satellites, all kind of different preferences. There's also an audible notification which bleeps when a satellite's in range. So that's what I like to use when I'm out and about portable. AMSAT online tracking, it's one method to just remind myself of any frequencies. What I use when I'm in the Shark, I use SatPC32. There's all different operating software available. I've tried Orbitron, I've tried Nova, I've tried Satscape. I've had some great experiences throughout the years playing around with different satellite tracking software. But I do always seem to come back to this particular one, as this does everything I need it to do. So some people say they like this, that and whatever, but like I said, I'm just giving you my personal preference. So SatPC32 is actually free. You can then pay a subscription which just gives you a few extra benefits, and it works perfectly fine on the free version. So set that one up. The thing I like about it, once you get familiarised with all the extras, you can set up the tracking software and it gives you the correct frequencies. So you can again find out what frequency is the downlink and the uplink. If you have the radio connected to the computer via the cat cable, it will then obviously change the frequency on the radio, and it'll also correctly set up, like I mentioned a minute ago, the correct modes like USB and LSB for the up and down links. So this is all a little bit confusing perhaps for some of you newbies, but basically that's how it does it simplified without having to think about it. I've selected various satellites as on the bottom of the screen, A to U I believe, and anytime I click on one of those alphabetical icons, the satellite frequency will change at the top, the radio frequency will match, and I will be tracking that particular satellite. So if I was on this one at the moment, which would be ISS, the frequency would be exactly the same on the radio. At the moment, obviously, that would be in the Pacific, so we won't be receiving anything in that footprint. So that's SAT PC32. On the right you can see the interface to the bottom, and you can see the control unit to the top. These are connected with CAT cables to the computer and configured using the rotor and CAT tabs on the top of the software, and also some of the setup. Fairly simple, and I've made previous videos showing you how to do that. But you don't need to have the fancy equipment to benefit from using SAT PC32. You can just run the software without any CAT cables and use it as a visual aid to find out where the bird is and what frequency it's operating on. You can also easily update the satellites by clicking on the satellite tab, and you can update it by choosing a database. I tend to use NASA Bare Elements, which is NASA Bare Elements. You'll see it on the list when it scribes down, and that's the current up-to-date position of all the satellites. They do vary, and it's quite surprising just how often such as the space station has moved position. So if you think you're aiming in the right direction, you could have missed it. So you've got to keep your what they call Keplerian elements or Keplerian elements, however you want to pronounce it, up to date, and that gives you the accurate pinpoint position of any satellite or anything that you want to track in space. Other methods of doing it or on the phone or with an Android tablet or an Android system, I've come across this particular software, Look for Sat, quite handy. As you can see, there's all different screens you can choose, set up the satellites you wish to track, and it's obviously good for the phone and works really well. So that's available on Google Play, simple download, and again free. So that's what we like to tell you about. So I use all these and very happy with them. This is how I find out about the satellites. So this question keeps on occurring: which are the active satellites? Which should we be listening for? So as a newcomer, and I know there's quite a lot of new people that have got into satellites, and I'm really pleased that some of the videos that I've been making have possibly inspired you to do that. So thanks for following, by the way, and subscribing. And this is how I find out about what is on the air, as it were, or what satellites are currently active. So it's called AMSAT Live Oscar Satellite Status, and it's just a page populated by radio amateurs like myself and many others that report when they've heard a particular satellite or space station. And this is currently updated throughout the day, every day, and it's the most accurate way of finding out which satellites are currently worth listening for. So you can simply click down the list or just look at the visual, and the red means that there's no signal, the blue means it's working perfectly. If it's a space station and you see purple, it means that the crew is active. If you see orange, it means there's some telemetry on the satellite, and yellow means you may have, oh sorry, it's the other way around. The telemetry is the yellow and the beacon, and the orange is the conflicting reports. That means that some people say it's on, some people say it's not on. So that's the one to worry about. But basically red or orange is bad news, and yellow, blue and purple is all good. So the ones I'm looking for are the blue, and that's where I get my information. For example, we can see that Alpha Oscar 73 at the top is active, that's an SSB sat. So is Alpha Oscar 7, and it says B, so that means it's on mode B. There's a couple of modes on Alpha Oscar. There's mode A and mode B, and all that is the uplink and downlink frequencies change, they kind of reverse, and so does the mode, such as LSB and SSB. But I won't bother going on about that too much at this stage. So as you go down the page, you can see which birds are active. Currently ISS data is working, so we've got the packet is up and running, but the ISS FM repeater has been off for the past couple of days, 3 days, so we're struggling with that. There's been no reports, but I think there may be a report of hearing the crew in there. I know the crew have been active making school contacts. So that's how we use the data to find out which active satellites are worth chasing and which ones are current. So that's on amsat.org/status/. Okay, this is the bit that you've probably been waiting for. This is the satellite frequencies, which I thought I'd share with you. So I'll post the frequencies in the comment below the video, the description. So satellite operating downlinks and uplinks, and we have the VU or the UV. So that's just basically VHF up, UHF down, or UHF up and VHF down, depending on which way around the VU is biggest, telling you the uplink. So to the right we've got the SSB, to the left we've got FM. If you're going to use handhelds and basic receivers, you want to stick with the FM birds, and the best way of doing this is to maybe channelize 5 or 6 channels with 5 kilohertz steps. So for example, let's have a look at SO50. So SO50 says D, which is downlink, 436795. So that's when the SO50 satellite is nearest or overhead. That will be where you'll hear it, at 436795. So when the satellite starts to come into reception range, the AOS, you'll hear it at 436805, and then as it gets a bit nearer it'll change to 436800, and then like I said, when it's in the perfect position, 436795. As it moves away, 436790, and finally as the path weakens, 436785. That's all on FM. I choose to operate wideband FM. I find it receives much better. So that's how you do it on all of the satellites. You can select 5 channels in your scanner, your receiver, your handhelds, your radios, whatever you're using, and program them in those steps. Or you can just simply start off at the high point of the pass and click down, but you need a 5 kilohertz separation to make it easy to navigate, unless you've got a VFO of course, like the FT847 that I use. But on the handhelds I channelize them. So the satellites on FM to the left with the frequencies, and to the right are the SSB sats. I find these a lot more fun. There is a bit more room for many QSOs in one go to take place. The FM birds are limited to 1 person talking at a time. The SSB birds, you can have 4 or 5, maybe 10, 12 QSOs all going on in the bandwidth that that satellite provides. So let's have a look at RS44 at the top of the list. So the uplink on that one will be on lower sideband, and the downlink will be on upper sideband. Most of the satellites, the linear transponders as they call them, are usually USB on the downlink, whether it be on 435, 436, 145. Generally find upper sideband is the receiving frequency and lower sideband is the uplink. So we'll be transmitting on 145960 lower sideband and receiving on 435650 upper sideband. That will vary, probably between, we'll say, the receive frequency will change up to between 670 and 630. So there's a big area, quite a few kilohertz bandwidth to operate in. It starts off at the higher point of the bandwidth and moves its way down as the satellite draws closer, gets overhead, and then as it's overhead it will be in the center point again, which would be 650, 435, 650 USB, and then as it moves away it will drop down to 435, 645, 640 and 635 and 630 if you've got a good antenna. So that's how all the satellites generally perform, and they're the frequencies. So I hope you've got a bit of information out of this video, and like I said, it's just on the fly as it were. No planning, no practice, just giving it to you raw. But yeah, maybe answers 1 or 2 of your queries, and I hope you're having lots of fun on the satellite band, and I hope to work some of you soon. Thanks very much for watching all my satellite videos, following the channel and subscribing, and I'm hoping to be back with you in a video somewhere real soon, somewhere near you. So in the meantime, with you the best 7.3 and the best satellite tracking and hunting, and keep up the good work. Catch you again. This is M0YKS, Satellite Chaser, from IO 93 Charlie United. Bye bye.